Okay, uh, this is the profile that we have designed earlier. Okay, we have 10% climbing lane, climbing section, and another 10% going down from road A to road B. So, okay, so now the gradient is considered to be okay because it is less than the what is the maximum from the tables. Um, so now we need to calculate for the vertical curve to fit in the curve uh, at these two straight lines lah. So the IP, you got the change from IP of the IP from the graph here, the change 60, and the height of the IP 51 meters. You get it from the Y axis, which is 51 meters lah. Okay, from the graph here. All right. Okay, for the calculation, okay, first you calculate A value. Okay, A value is positive 10, which is the first section here, positive, it's going up, and then minus negative 10. Negative 10, it is going down here, so it is negative 10%. So positive 10 minus negative 10 equals 20. It is positive, so it indicates that our curve is a crest curve. If our curve is a sag curve, this value is going to be negative. Okay, so K value from ATJ is 5. Here from the table, the K value is 5. So the minimum crest length for your curve here is L equals to 20 times 500 meters. So this is the minimum length. Okay, if you want a longer uh, curve length, it can also be done, but you need to make sure that the length of the curve does not goes over to the existing road. All right. So we use minimum length L is 100 meters. Okay. Height of A, height of point A. Point A is the first point, the tangent point uh, between the curve and this straight line. Height of A is 51, which is the height of the IP, minus 0.1 times 100 divided by 2. 100 is the length of your vertical curve. 0.1 is the gradient here, 10%. Okay, so you get 46 meters. HB is the same because it is equal. You also get 46 meters over here, but on the other side. HC, which is HA plus HB divided by 2, is 46 meters. And finally HD, okay, the peak of your curve is HC plus HIP. 46 plus 51 divided by 2, you got 48.5. Okay, so you see here, chain HA is 46, the height, okay, is 46, and the height over here is also 46, and the height in the middle point, okay, here is 48.5. Next, we need to calculate the change. Where is the location of point A, point B, and point D? Okay, so change of point A equals to change of IP minus half of your the length of your curve. Okay, your length is 100, so half of it is 50. So 60 minus 50 is 10 meters. Okay, here the other side. change of IP plus half of another curve, meaning that from here you minus half and from here you plus half. So you get 110. Okay. Change of D is same with change IP at 60 meters. So you can see it is at change 10. Another one is at change 110, and then the middle one is at change 60. So now you need to connect point A, point D, and point B using a flexible curve so that it becomes a curve lah. Okay. Okay, like so. So this is your design vertical alignment. Okay. So you need to make sure if you are using a longer curve, longer length of vertical curve, you make sure that this point does not go out of here of this the limit here, and this one also does not go out of the limit here. Okay. Next, we need to calculate the height at 10-meter intervals along our curve. Okay. Because we need to pass these heights to the excavator operator so that they will excavate the soil, the earth here, and get the exact profile of our road. Okay, the formula is HP. H, the height at certain points, equals HA that we have calculated earlier, plus or minus, depends on the slope, the gradient. In our case, it is plus because it is from channel A going up. It is a crest curve. So P is the value of the gradient. X is the distance from the channel A to our point of interest. Okay. So now we are calculating. So this is first station, 10 meters. The X value is 10 meters lah. Okay. For the second station, over here, change 30, the X value is 20 meters. Okay. From this station, the X value is 40 meters. So the X value increases. Okay. A is the value that you calculate earlier, negative A here. L is the length of the vertical curve, and X square is the X value. So at change 10, the starting of your curve, we already know from our calculation, the height is 46 meters. At change 20, you get is 46.9. Calculate for every point, change 30, 40, 50. Here at change 60 is the IP point. You use the formula to calculate, you must get 48.5 because your previous calculation shows that change IP here HD is 48.5. Okay, so it matches the previous calculation. So you continue calculating in 10 meters interval until you reach the final point. Change HB is 46 meter, and this also must be the same with your previous calculation.